Today's topic is trigonometry and area, and our objective is to be able to find the areas of regular polygons and triangles using trigonometry. So to review some review information, let's review some of the basic stuff we should already know. The area of a triangle equals 1/2 the base times the height. That should be an H. And the area of a regular polygon is 1/2 the apothem times the perimeter. And then we should remember our trig functions, which are sine, cosine, sine, and tangent. So the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over adjacent. And there is your SOHCAHTOA. So our first problem says that we have a nonagon and it has side length of 10. So let's draw in a nonagon. That's a 9-sided figure. So drawing in my nonagon, I don't know what helps you, but I kind of use templates if I can. I'm drawing in all the radii. Remember the radii, a radius is the distance from the center to the vertex of a regular polygon. And so those are the radii. To make this more lovely, we'll just put our center. There's our center. And I need to draw in my apothem, which is right there. Now I want to remind you that to find these things right here, they're called central angles, right? They're the ones that are at the center of the figure. So those are central angles. The central angle, a central angle in one of these figures is found by taking 360 and dividing that by the number of sides. This is a nonagon, so there are 9 sides. So each one of these angles is 40 degrees, right? They're all 40 degrees, including this one. And the apothem divides that in half. So this distance right here is 20. So that's a 20-degree angle. So I know that the side length is 10 because that's what the problem stated. So knowing that, that gives me that this distance right here is 5. So now I need to figure out the length of the apothem, right? Because to find the area of a regular polygon, I have to have the apothem times the perimeter. So let's take care of the easy stuff. The perimeter is going to be equal to 10, because they're side length 10. Remember, it's the sum of all the sides. But there's 9 of them, so instead of going 10 plus 10 plus 10, I'm just going to say 9 times 10. That's going to give me that my perimeter is 90. The apothem I'm going to find by using one of my trig functions, because I have the side opposite the angle, and I'm looking for the side adjacent. So opposite and adjacent tells me I'm using my tangent. So I'm going to find A by saying that the tangent of 20 is equal to the opposite, which is 5, over the apothem, which is A. And then I'm going to cross multiply and divide, and I'm going to get that A is equal to 5 over the tangent of 20. So to find the area, it's going to be 1/2 5 divided by the tangent of 20 times 90, which is the perimeter. So then the area is approximately 618.2. And the units are in, oh, let me see. The units are in centimeters, so there should have been 10 centimeters here. So the units are centimeters squared. Okay, so for our next problem, we're going to have a regular octagon. And the octagon has side lengths 7.5. So draw yourself an octagon. Let me label this one over here. This is a nonagon. Oops. There you go. Now we're going to do an octagon. The octagon, we're looking for area. The area of the octagon with side length 7.5 centimeters. So drawing my octagon, they're giving me the side length, so I'm going to need, that's going to let me get the perimeter. I'm going to need the apothem. So there's a radius, here's an apothem. And I know that the distance from here to there is 7.5, right? So the distance from here to there is 3.25. In case you can't read that. So then I'm going to find, first let's just do the perimeter. The perimeter is going to be 7.5 times 8 because there are 8 sides, right? Which is going to give you 60. And then I need to find A, that's this length right here. Oh wait, I need to find this internal angle first, right? I have to find the angles to do anything with the triangle. So again, the central angles all add up to 360. So I divide that by 8. That's going to give me 45. So the central angles are 45 degrees of my polygon, of my octagon. So that's 45 degrees, which makes this angle right here 22.5 degrees. So I have an opposite and an adjacent. So again, I'm back at my tangent here. So the tangent of 22.5 is equal to 3.25, the side opposite it, over the apothem, the apothem. And I'm going to cross multiply and divide. I'm going to get that the apothem is 3.25 over the tangent of 22.5. Then I'm going to put that into my area. The area is equal to 1/2 of the apothem, which is 3.25 over the tangent of 22.5 times the perimeter, which is 60. And when I multiply all that out, I get 271.6 centimeters squared. Okay. So now we're going to come up with something different. Now we're going to talk about a stop sign. So we have a stop sign. And our stop sign is an octagon, and it has a radius of 16.2 inches. And we are supposed to find its area. Okay, so first of all, let's draw our stop sign. Again, that's an octagon. So putting my putting my picture here. Again, a fast sketch, doesn't have to be beautiful. Here's my octagon. I'm going to draw in my radii and my apothem, because I know I need that to find the area of a regular polygon. And I know that the radii is 16.2. So this is 16.2. And I need to find the area of the whole thing. So I need an apothem, which is A, and I'm going to need this length here. So I'm going to call this piece X from here to here. And so the whole thing will be twice that. So let's find the side length first so we can find the perimeter. This is a, oh, again, we have to do a tangent, right? I'm sorry, we have to figure out my central angles. So the central angle is already 45, we already know that. So then half of that, this is going to be 22.5, because we figured that out on the last problem. So knowing that that's 22.5, I'm looking for the opposite over the hypotenuse. That is opposite over hypotenuse, my sine. So the sine of 22.5 is equal to x over 16.2. So x is going to be equal to 16.2 times the sine of 22.5. So then the perimeter is going to be equal to, this is an octagon, right? Let's make that note. This is an octagon. So it has 8 sides. So it's going to be 8 times 2 times this expression, 16.2 times the sine of 22.5. That's going to give me my perimeter. Then I need to find my apothem. So the apothem is actually equal to, well, I'm going to need the adjacent side and the hypotenuse. That's a cosine. So to find the apothem, I'm going to say the cosine of 22.5 is equal to the apothem over the hypotenuse, which is 16.2. And when I multiply across, I'm going to get that A equals 16.2 times the cosine of 22.5. So then to find the area of the stop sign, it will be equal to 1/2 this expression, 16.2 times the cosine of 22.5 times this expression, 8 times 2 times 16.2 times the sine of 22.5. If it's easier to put these all in, remember that what you're going to end up with is a rounding error if you choose to figure out the value for this and the value of this and round them off. Otherwise, you're going to plug all that in. You're going to find out that the area is 742.3. Inches squared. Okay. Now we're going to find the area of a triangle. So to find the area of a triangle, I'm going to draw in your triangle for you. Here's the triangle. So the triangle looks like this. I have this side, that side. I know that this is 12 centimeters. This is given. This is 21 centimeters. And this is 48 degrees. So the first thing I need to do is draw in an altitude, right? Because I don't have one. So I need to draw an altitude in. And I need to find out that value. So I have a side and an angle, and I need another angle. So this is my hypotenuse. This is my side opposite. That's sine, right? So then I'm going to find the sine of, I'm sorry, yeah, opposite. Sine of 48 is equal to the altitude over 12. And so A equals 12 times the sine of 48. And then I'm going to find the area, that's equal to 1/2 the base, which is 21, times the height or the altitude, which is 12 times the sine of 48. When I put all that into my calculator, that is approximately 93.6 centimeters squared. Okay, so that's how you use your trigonometry to find the area. Stop in tomorrow for the Zoom meeting and I will go over some other problems with you if you want to work on them. Have a great day.